Hi, I'm Sai Pratisha Potu. Today I'm going to cover the topic on comparison among different similarity measures. First, coming to what is similarity. Similarity is a state of being similar or similarity. It measures how much two objects are alike. A similarity measure in data mining context is a distance with dimensions representing features of the object. If the distance is small, two objects are very similar, whereas if the distance is large, then we will observe a low degree of similarity. Out of many similarity distance measures, I'll be comparing four of them: the cosine similarity, Euclidean distance, Jakarta distance, and the correlation. First, coming to the cosine similarity. Cosine similarity has often been used as a way to counteract Euclidean's problem with high dimensionality. The cosine similarity is simply the cosine of the angle between two vectors. It also has the same inner product of the vectors if they were normalized to both have length 1. Two vectors with exactly same orientation have a cosine similarity of 1, whereas the two vectors uh, diametrically opposite to each other have a similarity of -1. Here, their magnitude is not of the importance as there is a measure of orientation. Coming to the disadvantages, one of the main disadvantage of cosine similarity is that the magnitude of the vectors is not considered merely their direction. This means that the differences in values is not fully taken into account. Coming to the use cases, we use cosine similarity often when we have high dimensional data and when the magnitude of the vectors is not of the importance. Uh, For example, when a word occurs more frequently in one document over the another, this does not necessarily mean that one document is more related to that word. It could be the case that documents have uneven lengths and the magnitude of the count is of less importance. Then we can best be using cosine similarity, which disregards the magnitude. Then coming to the Euclidean distance. Euclidean distance between 2 points is either the plane or three-dimensional space in the measures the length of a segment connecting the 2 points. It is the most obvious way of representing distance between 2 points. Here the formula is calculated from the Cartesian coordinates of the points using the Pythagoras theorem. The disadvantages of the Euclidean distance are, although it is the common distance measure, Euclidean distance is not scale invariant, which means that distances computed might be skewed depending on the units of the features. Typically, one needs to normalize the data before using the distance measure. Moreover, as the dimensionality increases, the less useful Euclidean distance becomes. This has to do with the curse of dimensionality, which relates to the notion that higher dimensional space does not act as we want. Uh, individually expect from the 2 or 3 dimensional space. Coming to the use cases, Euclidean distance works great when you have low dimensional data and the magnitude of the vectors is important to be measured. The methods like KNN and HDP scan show great results out of the box if Euclidean distance is used on low dimensional data. Although many other measures have been developed to account for the disadvantages of your Euclidean distance, it is still one of the most used distance measures for good reasons. It is incredibly intuitive to use, simple to implement, and show great results in many use cases. Coming to the Jakarta distance, Jaccard index or intersection over union is a metric used to calculate the similarity and diversity of sample sets. The Jaccard coefficient measures similarity between finite sample sets and is defined as the size of the intersection divided by the size of the union of the sample sets. In practice, It is the total number of similar entities between sets divided by the total number of entities. For example, suppose uh, we have, if the two sets have one entity in common and there are a total of 5 different entities, then the Jakarta index would be 1 by 5, that is 0.2. Then to calculate the Jakarta distance, we simply subtract the Jakarta index from 1. Coming to the disadvantages, a major disadvantage of the Jakarta index is that it is highly influenced by the size of the data. Large data sets can have a big impact on the index, and it could significantly increase the union while keeping the intersection similar. Coming to the use cases, the Jakarta index is often used in applications where binary or binarized data are used. When you have a deep learning model predicting segments of an image, for instance, a car, the Jakarta index can then be used to calculate how accurate that predicted segment given true labels. Similarly, it can be used in text similarity analysis to measure how much word choice overlap there in between documents. Thus, it can be used to compare sets of patterns. Coming to the final one, that is the correlation. Correlation The correlation between two data objects that have a binary or continuous variables is a measure of the linear relationship between the attributes of the object. Correlation means association. More precisely, it is a measure of extent to which two variables are related. So coming to the formula, this is the correlation formula. We have 3 possible results of the correlation study: a positive correlation, negative correlation, and no correlation. A positive correlation is a relationship between two variables in which both variables move in the same direction. Therefore, let me just show you. Therefore, when one variable increases and as the other variable also increases, or if one variable decreases, the other variable also tend to decrease. Example of the positive correlation would be height and weight. Coming to the negative correlation, a negative correlationship is a relationship between two variables in which an increase in one variable is associated with a decrease in another. As an example of the negative correlation, the height above the sea level and the temperature. As you climb up the mountain, the increase in height, it gets colder. That is the decrease in the temperature. Coming to the zero correlation or no correlation, it exists when there is no relation between two variables. For example, there is no relation between the amount of coffee we drink and the level of intelligence we have. So a correlation can be visually expressed uh, through a scatter plot. It can also be called as a scatter graph or a scatter chart. So here you can see the diagrams. These are the points that we plot on the scatter plot. So the points that lie close to a straight line with which has a positive gradient, this shows that as the one area variable increases, the other variable increases. And in the negative correlation, the points lie close to the straight line which have a negative gradient. This shows that as the one variable increases, the other variable decreases. And in the other no correlation that has no pattern, this shows that the no correlation between the two variables. Coming to the disadvantages, correlation is not and cannot be taken to imply causation. Even if there is a strong association between two variables, we cannot assume that one We can assume that one causes the another. Correlation does not allow us to go beyond the data that is given. Coming to the use cases of the correlation, first is the prediction. If there is a relationship between two variables, we can make predictions about one from the another. Uh, one from the another. Coming to the validity, concurrent validity, correlation between a new measure and an established measure. Reliability, there are two types, and one is the test retest reliability, that are in which the measures are consistent, where the inter-rater reliability, where the observers are consistent, and the final one is the theory verification, that is the predictive validity. This concludes the comparison of the different similarity measures that I have chosen. Thank you.